Hello and welcome to high quality editing. You can clearly tell what this is just from that 2 over there. This is the second part of the computer test revision review. So now we're on units of measurement, which includes bits, bytes, kilobytes, gigabytes, terabytes and petabytes. So, bits and bytes. So a bit is a single piece of data represented as a 1 or 0 in binary, which means it is the one electrical impulse, as that's what binary equals, as we went over last time. So when 8 of these bits are grouped together, a byte is created. This byte is a collection of 1s and 0s, which can be used to represent denary numbers, from 0 up to 255 through binary, as I believe the total number of outcomes is 256, and 0 being a possible thing means that it only goes up to 255. So this shows us that 1 byte equals 8 bits, which means that 1 bit times 8 equals a byte, and 1 byte divided by 8 equals a bit. So let's go on to our next slide. So this is bytes, kilobytes, gigabytes and terabytes. So all other measurements follow a simple pattern involving bytes. Kilobyte is 1,000 bytes, a megabyte is 1,000 kilobytes, a gigabyte is 1,000 megabytes, a terabyte is 1,000 gigabytes, and a petabyte is 1,000 terabytes. Shown by this here, 1,000 of, so 1,000 times bytes equals kilobyte. 1,000 times kilobytes equals a megabyte. 1,000 times of megabytes equals gigabyte. And I don't mean this by times it by 1,000 to find out what that would equal, because that would be the complete opposite. If you wanted to find out what something in megabytes was in gigabytes, you divide it by 1,000, because a gigabyte is 1,000 megabytes. And that's basically what I'm trying to put across here. It's the exact same the other way around. As a byte is a 1,000th of a kilobyte, a megabyte is 1,000th of a gigabyte, which means that if you wanted to make it go down, you'd times it by 1,000. I did this last year, and I know I've written in a really confusing way, so just listen to what I said. Yeah, this was basically me doing some conversion, so turning kilobytes into megabytes by dividing it by 1,000. So as you can see, it's 2,168 and then to 2.168. So if we look back there, where are kilobytes and megabytes? So kilobytes is going up. So it's going up an extra 1,000, which means we must divide it by 1,000. It's similar with things such as other metric units. And next we have 2.168 megabytes, so we've got the same thing, and we're turning it into gigabytes, which means we have to divide by 1,000 again, which makes 0.002168 gigabytes. I cannot write very well on computers. 175 terabytes, and we're trying to find megabytes. So first we have to times it by 1,000, because a gigabyte is less than a terabyte, and then we have to, and then we get 17,500, and then we're going to times it by 1,000 again, because a megabyte's 1 less than a gigabyte. So overall we've times it by 1,000, and then we timed it by 1,000 again. We've done the process twice to get a very big number. So let's move on to the next slide. Binary addition. So I've decided this episode is just going to involve binary addition and binary shifts anyway, because I can't be bothered to put in another one. So binary addition without decimal conversion, so we don't need to convert it to a decimal. So how to add binary. If there is a 0 and a 1, the product is a 1. If there's a 0 and a 0, the product is a 0. If there's a 1 and a 1, the product is 0 and 1 in the next column. If there's 3 ones, if you're adding 3 numbers, the product is 1 and a 1 in the next column. So you start from the right as it has the smallest numbers. So if we look at the right here, we'd start by saying there's a 1 and a 0, which means in the lower column we can just put a 1. There's a 0 and a 0, which means in the lower column we need a 0. There's a 1 and a 0, which means we can just put a 1. There's 2 1s. Oh no, that means we can put a 0, carry 1 over. 0, 0. Oh look, 1, 1 again, which means we have to leave a 0, carry 1 over, 0, 0, which is good, 0, 1, put a 1 there. So that's an example of how you'd use it. And this thing called overflow, if there is 2 1s in the final column, there will be an error on the computer. This is as the 1s have overflowed the 8 binary digits possible. So basically, if there's a 1 and a 1 there, it can't possibly add that up. It can't move on to the next column because there is no next column to go to. As I said earlier, our next thing is binary shifts without decimal conversion, so you don't need to convert the decimals. It's basically how to multiply and divide binary. So every space number is moved to the left, it's times by 2, and every space it's moved to the right is divided by 2. So as we can see, this is our original number. If it's divided by 2, then we go one way that way, which makes a lot of logical sense, as the things at the top, that's 1, that's 2, that's 4, that's 8, and if you divide any of these by, all of this by 2, it just moves it down one layer, which makes all the numbers divide by 2, which makes a lot of sense. So it's divided by 2 will shift along, divided by 2 will shift along, and if it's divided by 2 twice, that's divided by 4, and 4 is 2 squared. So what I've done on this side, okay, so this is the same, we're just moving it 1 space that way every time we times it by 2, which makes sense again, as if you, each of these numbers as it goes up 1, it's being times by 2, so overall the overall outcome is times by 2. If you do something for everything, it will do it to each one. Oh no, wait, go back, we're not doing that now, we'll do that next video. So let's just go back to the beginning. That was Computing Test Revision PowerPoint 2. Okay, goodbye.